Somewhere in central France there is a cave. It is dark, damp, and smells like something between earth and sweat. Inside, thousands of wheels of cheese sit on wooden shelves, slowly aging. Mold creeps across their surfaces. Bacteria work through their cores. The cheese will not be ready for months. Now picture a courtyard in rural China. Rows of clay jars sit under the open sky, sealed with cloth. Inside each jar, soybeans are breaking down, dissolving into a thick, dark liquid. It will take a year, maybe two, before the sauce is ready. 2 places, 2 ingredients, 2 completely different products. But the same invisible force is at work in both. Fermentation. Microorganisms eating, digesting, transforming. The same biology, the same chemistry. So why did these 2 civilizations end up in such radically different places? The answer is not about Tatehead. It is about genetics, land, and a fork in the road that happened thousands of years before anyone knew what a microbe was. Fermentation is one of humanity's oldest technologies. It predates writing, predates agriculture, predates civilization itself, and it was almost certainly discovered by accident. A herder in ancient Mesopotamia stores milk in a pouch made from a calf's stomach. Days later, the milk has solidified into something strange. Tangy, firm, edible. The enzymes in the stomach lining curdled the milk. He did not know why. He just knew it tasted good and lasted longer. Thousands of miles east, a similar accident. Soybeans left in salt and water for too long begin to darken, soften, and develop an intense aroma. Someone tastes the liquid. It is salty, rich, almost meaty. They do not throw it away. They make more. Long before we understood why fermentation worked, we knew that it did. Leave milk in a warm pot, and it thickens. Leave soybeans in brine, and they transform. Leave grape juice in a barrel, and it becomes something far more interesting. The principle is simple. Microorganisms, bacteria, yeasts, molds, consume sugars and proteins in food. They break them down, and in the process, they produce acids, alcohols, and hundreds of flavor compounds that did not exist before. Fermentation does not just preserve food, it creates entirely new foods. Every civilization on Earth figured this out. The Egyptians brewed beer, the Mesopotamians made bread, the Koreans made kimchi. But when it comes to the sheer scale and diversity of fermented foods, 2 traditions tower above the rest: Europe and China. Europe built its fermentation empire on milk. Cheese, butter, yogurt, kefir, crème fraîche. France alone produces over 1,000 distinct varieties of cheese. Each valley, each microclimate, each breed of cow or goat contributes something different. It is an ecosystem of flavor built entirely on a single animal product. China went the other direction. Its fermentation empire was built on soybeans. Soy sauce, doubanjiang, fermented black beans, stinky tofu, chow miso. Though miso is more famously Japanese, its roots trace back to Chinese jiang. Hundreds of variations, each with its own regional character, its own aging process, its own strain of mold. Same technique, completely different raw materials. And that difference shaped everything. From what people eat for breakfast to how entire economies are structured. But here is where it gets interesting. This was not a choice. Nobody sat down and decided milk was better than soybeans, or the other way around. The split was determined by forces far older and far more stubborn than culture, scarred with biology. Most mammals stop digesting milk after infancy. The enzyme that breaks down lactose, the sugar in milk, simply shuts off. This is the default setting for humans too. Most adults on the planet cannot comfortably digest milk, but somewhere in northern Europe, roughly 7,000 to 10,000 years ago, a genetic mutation appeared. People who carried it kept producing lactase into adulthood. They could drink milk without getting sick. And in a cold, harsh environment where calories were scarce, that was a massive survival advantage. The mutation spread. Over thousands of years, it became the norm in Europe. Today, roughly 90% of people in Scandinavia and Northern Europe carry this mutation. In East Asia, that mutation never took hold. Around 90% of the population in China and surrounding regions are lactose intolerant, not because something went wrong, but because nothing changed. They kept the original human setting. This single biological fact rewired everything. If your population can digest milk, you build your food system around dairy animals. If it cannot, you find protein somewhere else. But genetics alone did not make the decision. Geography finished the job. Europe had vast grasslands, cool climates, and rolling hills. Perfect terrain for grazing cattle, goats, and sheep. A single cow needs about 2 acres of pasture. In Europe, that land was available. Dairy animals thrived, milk was abundant, and the surplus had to go somewhere. Cheese was the answer, a way to store liquid milk as solid food that could last months, even years. China faced the opposite equation. Its heartland was river valleys, the Yangtze, the Yellow River, where every acre of fertile soil was precious. That same land a European cow needed could grow enough rice or soybeans to feed an entire family. Raising cattle for milk was, in economic terms, irrational. The math simply did not work. So protein came from the soil, not from animals. And from that soil came the soybean. Domesticated in China around 3,000 years ago, it was the perfect crop for a densely populated civilization. Cheap, easy to grow, and remarkably rich in protein. But what made it truly extraordinary was what happened when people stopped eating it fresh. Because the soybean responded beautifully to fermentation. When you introduce the right molds, particularly a fungus called Aspergillus oryzae, it breaks down soybean proteins into amino acids. Among them, glutamate, the molecule responsible for umami, that deep, savory taste that makes food feel complete. This is where the story takes a surprising turn. Because Europe's greatest cheeses do exactly the same thing, just with a different starting material. When milk ferments and ages into something like Parmesan, its proteins break down into the same amino acids, the same glutamate. The same umami, Parmesan, and soy sauce are, in biochemical terms, distant cousins. Both are concentrated umami delivery systems. Both achieve their depth of flavor through the patient, slow work of microorganisms breaking proteins apart. One starts with casein from milk, the other starts with protein from soybeans. But the destination is remarkably similar. This is not a coincidence, it is convergent evolution. The same survival pressure producing the same solution through completely different paths. Humans everywhere crave umami. It signals protein, nutrition, sustenance. And on opposite sides of the world, two civilizations independently found ways to concentrate it. The parallels run deeper than cheese and soy sauce. Consider cabbage. In Germany, they shred it, salt it, and let lactic acid bacteria transform it into sauerkraut. Tangy, crunchy, and packed with probiotics. In Sichuan, they do nearly the same thing. Suanchai, literally sour vegetable, uses the same salt and thyme method, the same bacteria, and produces a remarkably similar result. Or consider cured meats. European prosciutto hangs for months in cool cellars, developing complex flavors as enzymes break down muscle fibers. Chinese lapchong, cured sausage, undergoes a similar process, air-dried and aged until the fat renders and the flavors concentrate. Different spices, different cuts, same underlying principle. Everywhere you look, the same pattern repeats. The technique is universal, the ingredients are local, and the local ingredients were determined not by preference, but by geography, climate, and genetics. But that ancient divide, cheese on one side, sauce on the other, is no longer as clean as it used to be. Something unexpected is happening. The walls are coming down. China's dairy market has exploded in the last 2 decades. Yogurt consumption has grown so fast that China is now one of the largest yogurt markets in the world. Young people in Shanghai and Beijing eat cheese on pizza, spread cream cheese on toast, and drink lattes with steamed milk. A generation that grew up largely without dairy is adopting it at remarkable speed, even though their genes have not changed at all. Meanwhile, in the West, fermentation is having its own revolution, and it is borrowing heavily from the East. Miso paste has become a staple in high-end kitchens from Copenhagen to New York. Chefs at Michelin-starred restaurants use koi mold to age steaks, create plant-based charcuterie, and develop new sauces that did not exist a decade ago. Kombucha, a fermented tea with Chinese roots, sits on supermarket shelves in Los Angeles next to orange juice. The most innovative chefs in the world are no longer working within one tradition. They are combining both. Miso butter on sourdough bread, koji aged beef with Gruyere crust, soy sauce caramel on French pastry. A restaurant in Copenhagen serves a dish made entirely with koi fermented barley that tastes remarkably like aged cheddar, but contains no dairy at all. These are not gimmicks. They represent a genuine collision of two fermentation philosophies that evolved separately for millennia and are now meeting for the first time. And this convergence reveals something profound. The divide between European and Chinese fermentation was never really about opposing philosophies or incompatible palates. It was about circumstances. Give a population milk and they will make cheese. Give them soybeans and they will make sauce. The human impulse, to harness microbes to transform the raw into the extraordinary, to create flavor where there was none, is exactly the same. Go back to those two places. The cave in France, the courtyard in China. In the dark, a wheel of Comté is slowly developing its nutty, crystalline interior. Under the sun, a jar of soy sauce is deepening into something rich and almost impossibly complex. Different ingredients, different climates, different histories. But in both places, the same ancient partnership is at work. Humans and microbes, doing what they have done together for thousands of years. Turning patience into flavor, turning time into taste. Taking something ordinary and, through nothing more than waiting, making it extraordinary. The cheesemaker in the French cave and the sauce maker in the Chinese courtyard have never met. They speak different languages, use different ingredients, and serve different traditions. But they share the same faith, that if you give the right food to the right microbe, and then step back and let time do its work, something remarkable will happen. They have more in common than either of them might think.